All right, so let us move into what happens when we now multiply instead of just adding or subtracting algebraic terms. All right, so we have seen something along the lines of 2x plus 3x minus 5x. This is what we did previously. And this was 2x plus 3x equals 5x minus 5x equals 0. And we do it term by term. Very nice. However, this is often going to now be the second line of working after what we're going to learn about today, which is multiplying a monomial by a bracket, which could be a binomial, a trinomial, or anything more. So if I say to you, 4 times x plus 2, and I say to you, please simplify this. People who have gone through this bit of knowledge already, they'll know immediately what to do. Now, I'm going to treat this a little differently to what you were initially thinking. I want you to take a little gander or look at the following idea. If I say to you, I have 4y, I can expand this 4y into saying y plus y plus y plus y. And everyone understands this. So this is absolute basics of algebra. If we're adding together with the same variable, you can say that there are that many of that variable. Great. But now this over here looks far more complicated. But in actual fact, it's the exact same concept, where this whole thing here is essentially the y. So we're going to expand this out and then show that we can add them together. So 4x plus 2 is x plus 2 plus x plus 2 plus x plus 2 plus x plus 2. And I know that my signs in the front are plus, and when they are a plus, that means that my brackets have no impact on the sign. So I don't need my brackets at all. Great. So now that my brackets are gone, I'm even going to just make it a little bit neater. Brackets totally gone. I can now add these together. And remember, we add using like terms. So x plus x is 2x. Plus x is 3x, plus x is 4x. And then I've got a 2 plus a 2 is 4, plus a 2 is 6, plus a 2 is 8. Great. But, I mean, if that number 4 is far larger, let's say 25, I don't want to write out x plus 2 25 times. That's really wasting my life. So can I find a relationship between this 4 and what it's done to this x plus 2 to create this answer? Well, I can indeed see this relationship. And this relationship is saying that 4 times by my x gives 4x, and I know I'm multiplying the x by 4 because I have 4 of them. And then separately, let's choose green for this. Separately, I'm taking the 4 and I'm multiplying it by the 2. And that's because I have 4 2's that I'm adding together. And 4 times 2 does give me 8. So we can see that we can actually take the 4 and multiply it individually to any of the terms, and by any, I mean all of the terms, inside the brackets. Now, that essentially, knowing that, shows us a specific rule. And this rule I'm going to write in purple because I can. This is known as the distributive law. Distributive law or distributive rule, it doesn't matter. I prefer the term law because it's something that must never be broken. So, the distributive law states that if you have a monomial being one term on the outside, and you are multiplying it into brackets that have more than one term, being a binomial, like it is here, 2 terms, a trinomial, 3 terms, or more, then you simply take this monomial and multiply it by each term individually to expand out the brackets. Well, that is very important to know, because when dealing with multiplication, that is where we come to our area and items like that. So let's do another one. Let's go back to red. So what about if I say, let's go 8 times 2x minus 3y. And I need to simplify this. Well, I see this is a monomial multiplied into brackets with a binomial inside. And therefore, I'm going to multiply the 8 onto the 2x and the 8 onto the minus 3y. Please note I'm including the sign in when I multiply. So 8 times 2x, well, I just multiply the numbers. 8 times 2 gives me 16, and then x minus 3y is multiplied by 8. So 8 times minus 3 is minus 24, and then I have my y. And it is literally that simple. Nothing more that we need to know about. What about if I have something like 3x times 2x minus 3y? So this seems to be a little bit more complicated, but it's the exact same scenario. We do the exact same thing. So 3x times 2x, well, let's multiply the numbers first. 3 by 2 is 6. And then x times x, we've dealt with this already. If you're multiplying with the same variables, x times x becomes x squared. And then over here, 3 times minus 3y, 3 times minus 3, that gives me minus 9. And then multiply my x, x times y. Can I join them in some way? No, because they are different variables. So we can't have something like x squared or y squared or x squared, y squared, or something like that. They don't join. So it's literally just x, y, to show that there was one x and one y being multiplied. Remember, if we don't see anything in between them, we know that it's automatically multiplication. And that is the answer. That's it. So we can see that this sort of multiplication is the opposite of factorization, because factorization looks to take out a common factor, and this distributive law looks to put the common factor back in. All right. All right, you guys. So after this, let's have a look at something maybe with 3 terms. So I'm going to make my monomial even more involved. So let's say minus 2x squared y. A bit more of a complicated monomial. So let's see, this could be multiplied by 3x minus 3y plus xy. All right, so here's my monomial, here is my trinomial in the brackets, and all that happens is you take my monomial and we multiply it in. And we're going to multiply it in by the first term, the second term, and the third term. All right. So, minus 2x squared y times 3x. Doesn't matter how complicated these things look, you always do it step by step. Number, variable, 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 however many variables there are, and you're done. So minus 2 times 3 gives me minus 6. X squared times x gives me x cubed. Because remember, this x has a power of 1. When you're multiplying with the same bases being x, you add the exponents together. And then we have a y here and nothing there, so my y just follows suit. And that's my first term. Then I multiply to the second term. Minus 2x squared y times minus 3y. Now remember, minus 2 times minus 3 gives me plus 6. This is very important. This is often where you lose your marks, and it's for absolutely nothing more than stupidity. Minus times a minus gives a plus. It is very important. All right, so we've got the minus 2 times the minus 3 gives plus 6. We've got an x squared, nothing over here, so my x squared just follows us. I've got a y and a y. Y times y gives me y squared because they are the same variable, so I can add the exponents. And then that is my second term. Now I simply multiply my third term. Minus 2x squared y, all the way across to multiply by my plus xy. So what number is in front of my xy here? Well, I don't see anything, which means I automatically know that the number is 1. So minus 2 times plus 1 stays at minus 2. I have an x squared times by an x. That gives me x cubed. And I have a y times by a y, giving me y squared. And that is my answer. You see, we are literally doing the exact same thing. We're literally just doing it 3 times. We're doing it as many times as there are terms in the bracket. All right, not very complicated. So this sort of idea can roll onto where we have something like perimeter. Because if I give you a shape like this, and let's say this length is x plus 2, and this length is y, I can say to you, calculate my perimeter and calculate my area. Well, we've done perimeter. Perimeter is this side plus that side, plus that side, plus that side. Well, I know that this was a rectangle since I mentioned it was a rectangle. So this is x plus 2, and this is y. So my perimeter is x plus 2 plus y plus x plus 2 plus y. So that is x plus x is 2x, y plus y is 2y, and 2 plus 2 is 4. We've done that. We can do that. What about area? Well, area, I need to multiply these together because the area of a rectangle is my length times my breadth. So that would be y times x plus 2. And this is now where we use our distributive law. So y times x gives me either yx or xy. It's a good convention, though, that when you write down variables, you write them down in alphabetical order, though. So that becomes xy plus, and this is y times plus 2. So this is 1y times 2, which makes it 2. And there's no y's over here to multiply with that y. So we just get the y to follow. And that is my area, xy plus 2y. So this is quite a major application of this distributive law. And you're going to be finding later on in forthcoming videos that this monomial can also change to a binomial. And then we're going to have a binomial times another binomial. Luckily, all it is just distributive law again. All right, let's do another area question. So what about if I have the following? I could have, let's think of a shape. All right, let me give you a bit of a tougher shape. Let me do it like this. Great. So this side is x plus 3, that whole length. This side is 5. This side is y. That side is 2. And I say to you, calculate perimeter and calculate area. So perimeter, again, is the outside edges. But we don't have all our sides. We are missing this one, and we are missing this one. So if we have a look at the vertical side first, this whole thing is x plus 3, and all of these are right angles. I'm going to tell you now. I should have mentioned it initially. So I know then that this side plus 5 gives me x plus 3. So my unknown side plus 5 gives me x plus 3. Take my 5 to the other side. I can subtract 5, and I get x minus 2. Because 3 minus 5 gives me minus 2. Great. So that makes this side x minus 2. And similarly over here, my whole side is y. This side is 2. So I've got to take 2 off of y, which makes that y minus 2. So to sum my perimeter, I have y plus 5 plus y minus 2 plus x minus 2 plus 2 plus x plus 3. Notice I don't have any brackets. The reason I don't have any brackets is because I'm adding, and therefore brackets are unnecessary. So now I have y plus y is 2y. I have x plus x is 2x. And then I have plus 5 minus 2 gives me plus 3. minus 2 gives me plus 1, plus 2 gives me plus 3, plus 3 gives me plus 6. A perimeter. Great. What about my area? Well, area of this shape, I'm going to have to break down because this is not a regular shape. So I'm going to have to break this shape into smaller shapes. That color is not very easy to see with the red. So I'm going to choose a light blue. Great. I'm going to break it over there. And this is shape 1, and this is shape 2. Then to calculate my whole area, it's going to be shape 1 plus shape 2. We can do that. So how are we going to do this? Well, shape 1 is a rectangle, and it's going to be that length times that length, which is 2 times x plus 3. So 2 times x is 2x, and 2 times plus 3 is plus 6. And then if we look at shape 2, we've got y minus 2 there, and 5. So we're going to multiply that side by that side. So it's y, let's put the 5 first, 5 times y minus 2. So 5 times y is 5y. 5 times minus 2 is minus 10. Very important. And now these two we're going to add together. So finally, my area is going to equal 2x plus 5y, and then I've got plus 6 minus 10, because a plus minus just makes a minus still. So plus 6 minus 10 gives me minus 4. And that is the area of my rectangle.